So hello students, see page number 134, the topic importance of the universal law of gravitation. So the universal law of gravitation successfully explained several phenomena which were believed to be unconnected. So point number 1, the force that binds us to the earth, the motion of the moon around the earth, the motion of planets around the sun, and the tides due to the moon and the sun. So this law of gravitation successfully explained this phenomena. Okay, now see the next point, free fall. So let us try to understand the meaning of free fall by performing this activity. So take a stone, throw it upwards, it reaches a certain height and then it starts falling down. So from this we have learned that the earth attracts objects towards it. This is due to the gravitational force. Whenever objects fall towards the earth under this force alone, that is due to this gravitational force, okay, we say that the objects are in free fall. So is there any change in the velocity of the falling objects while falling? There is no change in the direction of motion of the objects, but due to the Earth's attraction, there will be a change in the magnitude of the velocity. Any change in velocity involves acceleration. Whenever an object falls towards the Earth, an acceleration is involved, and this acceleration is due to the Earth's gravitational force. Therefore, this acceleration is called the acceleration due to gravitational force of the earth, or simply we call it acceleration due to gravity, and it is denoted by small g. Okay, it is denoted by small g. Small g is the acceleration due to gravity. Okay, now see, we know from the second law of motion that force is the product of mass and acceleration. Let the mass of the stone in activity 10.2 be small m. We already know that there is acceleration involved in falling objects due to the gravitational force and is denoted by small g. Therefore, the magnitude of the gravitational force F will be equal to the product of mass and acceleration due to gravitational force, that is F equal to mg. This is equation 1. We can write force equal to mass into acceleration. We already learned it. Okay, now see, again gravitational force, we can write F equal to g m by d square. Okay, so we can equate this mg, we can write mg equal to g by d square, and from this if we cut this small m and small m, we got g equal to small g equal to capital G m by d square. Here small g is acceleration due to gravitation, acceleration due to gravity. Okay, and capital G is already discussed. Capital G is gravitational constant. Okay, now see, and see again, m is the mass of earth. This capital M is the mass of earth, and small d is the distance between the object and the earth. Now see, let an object be on or near the surface of the earth. So the distance d will be equal to r, capital R. Capital R is the radius of earth. Thus, for objects on or near the surface of earth, we can write this one. Okay, mg equal to capital G capital M into small m divided by r square, and here if we cut this m and this m, we got this equation. Okay, so we got g equal to capital G capital G into capital M divided by r square. So here small g is acceleration due to gravity. This capital G is gravitation constant. This capital M is the mass of earth, and this r, capital R, is the radius of earth. Okay, so this equation, remember this one equation. Now see, the earth is not a perfect sphere. Okay, we know the earth is not a perfect sphere. As the radius of earth increases from the poles to the equator, so the value of g becomes greater at the poles than at the equator. Okay,